We'll be starting up in about, a little over a minute, minute and a half. We'll give folks a few minutes or a few seconds to finish logging in. I'll be the disembodied voice in the background.
You might be the main portion. I might be the disinvited portion.
Okay, it looks like we got a big crowd. Numbers have stopped going up, so we'll go ahead and get started. Good morning. We have a nice timely subject for the first of our summer webinars. Um, This is Erosion, Ditches, and Storm Sewers, and it's going to be taught by Geoff Scott, who's our technical assistance engineer. I'm David Orr. I'm the director here, sitting in the background, along with Jody, Amanda, and Michelle, and we'll get everything taken care of. So what you got in the next slide there, Jeff? That's the update stuff, I think. Yep. If you haven't been on one of these webinars before, lower left is your audio settings. You want to open up your chat pod. That's where you can get a link to the handouts and stuff like that. You want to also know up the Q&A pod. That's where you'll be able to put questions in, and we'll be watching for those. If you have any questions, please put them in there. We get your questions answered for you pretty quick. This is worth 1 PDH here in New York State, and technically it's a course. It's the only person registered, and we'll send you a certificate of attendance later on. If you're from outside New York, you'll need to check with your LTAP center. We just handle the New York LTAP stuff. Okay, time for those polls there, Amanda. Who do you work for? Town, county, city, village, state fed, tribal, private?
Weekend.
Everybody's working for the weekend. Okay, well, I actually got quite a blend there. But again, pretty timely with all the rains we've been having. Okay, that's good. And then our next question. How long have you been in the position? We'll, less than a month up to 20 plus years. Let's see what we got there. We have a couple of people, Jeff, who are less than a month on the job, dealing with one of the wettest springs and early summers we've ever seen. And good variety again. So folks all the way up to 20, quite a few over that. That's good. And then finally, pretty important, what is your job? Are you in administration? Are you the highway official, engineer, field crew, board member? None of the above. If you put none of the above, do us a favor and type into the pod what is your, what is your job, so we just have a sense of what that is. That can help us later on. And then most of your engineers, about 3/4, it looks like. Probably want those PDHs. Okay. Okay. You can close that poll down. We have a project manager. Okay. Okay, well then I'm going to go silent. We're going to let Jeff get started with this, and enjoy your hour. Go for it, Jeff.
All righty. Where'd I go? All righty. Get rid of this little screen in my way. Well, good morning. We're going to talk about erosion, ditches, and storm sewers today. We'll start off by talking about watersheds. This thing's not working well for me. All right. All right. New York State technically has 17 major watersheds. They all drain in different directions. Some drain into Connecticut, some in the Champlain, St. Lawrence, the Great Lakes, Lake Ontario up in this way. You got this portion here drains into Lake Ontario. This whole Finger Lakes area drains in along Ontario. Even this river here runs all the way back up. That's the Genesee River, runs from Pennsylvania all the way into the Great Lake Ontario as well. This drains into Lake Erie. These two little portions here actually drain down into Chesapeake Bay. So you've got a bunch of different directions that we go. This one actually drains into the Mississippi and out into the Gulf of Mexico. So we drain in a bunch of different directions. We got a lot of contributing watersheds here that go different directions, but they all, again, it's all something we got to talk about. We all live in a watershed. And when the rainfall lands on impervious surfaces or compact soils, instead of it percolating into the ground, it tends to go into runoff and heads to each of these little water, these lakes that they head to, and rivers. So there's hundreds of miles of ditches that crisscross each of these watersheds. While the ditches drain the roads, they can officially intercept the runoff from each of the hillsides as well. They capture about 20% of the rainfall inside that watershed. But typically when they collect that, they'll accelerate the velocity in those ditches and cause additional problem on top of that. Let's see if I can move this thing out of the way. It's annoying. Oh, that's better. Gets rid of me too. All right. So erosion's nothing new. Shot of the Grand Canyon, you can tell that erosion's been happening for centuries. Beginning of time, essentially. If it's left unchecked, you can get situations that we're seeing right here. So essentially erosion is the removal of the soil by water, wind, ice, and gravity. In this case, it's probably mostly water and wind. But again, if the soil is left unprotected, you're going to get that erosion. So it's difficult to stop once that erosion starts. So the best method is basically try to prevent it. Many maintenance activities could actually avoid a lot of erosion, just put a little bit of maintenance in the beginning. The numbers go is about 30 tons of sediment material can be eroded from a mile of ditches before it's even noticed. That's a lot of work to remove 30 tons of material out of a ditch. Erosion comes in a variety of different types. Again, different stages of it as it goes through. We've got the raindrop, surface, rill, gully. But essentially, erosion is basically the dislodging of particles of soil. With the raindrop erosion, essentially it starts with the raindrop as it hits the ground. The raindrops typically hit the soil surface at about 25, 30 feet per second. When you hit a loose piece of soil or an uncovered soil, that particles can be dislodged fairly easily. So again, once it detaches that soil particle, and you get a lot of raindrops, you get a lot of detached particles of soil, and once they start getting mobile, that's where you start getting a lot of that sediment transfer. Again, sheet flow is your next run through. Surface erosion, once it starts moving, that sheet flow will start to carry a lot of that sediment, and that you'll see a lot of the particles will actually be discolored, be brown colors in most cases. Again, this can happen when the soil gets either too saturated, in cases like we're dealing with in New York nowadays, at least this spring. We got a lot of saturated soil, a lot of full streams, a lot of full ponds. So the easiest course and the path of least resistance is basically travel across the surface. This leads to scouring of the exposed surface and runoff, which can result in additional runoff and then further erosion. Once that sheet flow starts to channel, in the very minute sense of it, you can get that rill erosion. That's concentrated flow basically develops into rivulets or well-defined channels, and it can be up to several inches deep. That's when you're starting to get a little bit higher velocity. You're creating these little narrow channels on banks and slopes. And once that runoff gets concentrated, you're going to start seeing a lot more damage as it goes through. Even in stockpiles, it happens. Again, you can see at the bottom in this lower portion here, where they've got a lot of that fine material around that basin inlet. Again, if we can avoid that, you can avoid cleaning those basins later on as well. Again, then there's gully erosion. Once the rills and grooves get left unrepaired, the velocity of the flow becomes greater. You're going to that velocity of that flow is actually going to dislodge a lot more material till you hit rock. So a lot of that loose soil or the resistance of that soil to restrict a lot of that movement is gone. It basically goes downhill with that. Again, that can happen on large scales. It can happen even in a rainstorm where the rainfall can't get it off of the ditch, as in this case, can't get off of the road into the ditch because there's a berm along the roadway. So it can once it Once it travels, again, water will take the path of least resistance and will cause its own problems and will cause its own path, but it'll do and create problems as it goes. Again, there's a lot of issues that are out there. Erosion get a little bit close to that cemetery, you're gonna have a lot more problems than just sediment. Oops, where do we go? A lot more problems than just sediment going down slope. Again, by moving the sediment and removing all that stabilized material, it's going to cause uh, erosive issues downstream. Again, it happens along the road too. Not only does it remove the sediment, but as that sediment goes, it picks up a variety of different pollutants as it goes downhill. So again, moving that unstabilized soil um, can be easily moved if it's not protected and maintained. In some of the sedimentation problems are pretty obvious. If you've got loose sediment, you can see where it's actually collecting along the road. May fill your culverts, may fill your ditches. Again, that leads to additional work that preferably be avoidable if it's all possible. One of the more damaging issues comes when it's, you might not see some of the obvious erosion upstream, but as it gathers into the local streams and rivers and get channels out toward the larger lakes, they're picking up that sediment. Once that sediment basically travels into these lakes, as that velocity decreases, that sediment settles out. And basically what happens is it settles to the bottom. It starts covering up a lot of the aquatic vegetation, which will reduce the production of oxygen within those water bodies. But it'll also settle onto some of the smaller aquatic invertebrates and small animals that are in there and basically smother them out, suffocating them. Not only that, but that sediment moving down through there will also bring pollutants into that water body that can, again, be detrimental to the aquatic life within there. And in some cases, it just gets worse. The first picture was the Adirondacks. This is actually Cayuga Lake. So the issue is not isolated to one area. It's pretty much across the street, across the state. And it's something we all need to take a look at and try to maintain as we go. And as I mentioned, a lot of the pollutants that are transferred through here. The sediment will pick up a lot of those pollutants as it travels down. Can pick up debris, chemicals, nutrients, organic compounds, salts. Some of the debris, the gross solids, essentially trash, leaves, litter, organic debris. A lot of that can result in human illnesses, particularly if it ends up in a water body that kids or people are swimming in. The chemicals, again, you don't necessarily see them, but they certainly do show themselves, including the nutrients. You get these algae blooms. Freshwater, you get phosphorus, and salt waters, you get nitrogen. Again, what they do is they'll accelerate the growth of algae, which will, as you see on the right here, will actually cover up the growth, the light going to the bottom of that water body and actually smother it out. Again, when it biodegrades, it actually gobbles up a lot more oxygen as it decomposes. Again, some of the other chemicals might also be heavy metals, organic compounds, hydrocarbons, which are fuels, and they can all end up causing cancer, birth defects. Again, there's always the potential of moving some of those chlorides as well. And that can be detrimental to a lot of the microinvertebrates and some of the freshwater fish. So the water quality impacts can be quite substantial, and you don't even really realize it. And covering your salt piles is going to be critical. Do a good job. If you get a salt pile like this, it's not protecting that rainwater from filtering through that pile. As you can see, all that salt has been taken out of that pile of soil, that pile of sand, and is now migrating downhill. So some of the factors that influence erosion, again, the soil erode, we'll talk about these: soil erodibility, vegetative cover, topography, climate, even the time of season is critical. Some of the soil erodibility, basically the vulnerability of soil to erosion, basically comes down to the structure, the texture of the soil, organic material within that soil. Again, most of the erodible soils are generally in a high proportion of silt and very fine sands. But again, as the strength of that water gets going, more of that soil becomes erodible as it goes through. The presence of clay sometimes, except dispersive clay or organic matter, can tend to decrease that soil's erodibility. Clays tend to be sticky and bind together, and organic matter tend to stabilize the soil basically by holding it together. So again, there's going to be some structures or some factors that are going to help soil structure, but again, soil erodibility is going to be critical. And again, some of the erosion risks, this is out of the Blue Book, Appendix A of the Blue Book itself, the new one, of course. You can tell the different types of soils with the different percentage of slopes and what the potential for erosion is going to be. As you can tell, the gravelly ones are going to be a lot less prone for erosion. Of course, till you get the steeper ones, anything with a little steep slope is going to have a lot more potential to be dislodged and move. You can see the sands, they're the smaller particles, they're going to be a little bit more prone to moving. Silts as well. Again, the dispersive clays tend to hold each other. Not the dispersive, but the regular clays tend to attach to each other. But the dispersive clays, again, on the other hand, are not. So again, there's measures out there as means of checking out depending on the type of soil you have. So again, just being aware that the sources are out there. Vegetative cover. It protects the soil from those erosive forces and the raindrop impact. And then the runoff scour in several ways. If you've got top growth, vegetative growth on top, it shields that soil from raindrop impact, while the roots hold the mass of the soil particles together. Grass buffer strips, I use them a lot of times in trying to protect and minimize erosion in agricultural situations. Again, they can be used to help filter out some of the sediment so you don't lose all that topsoil. The grass slows the velocity of the runoff and also helps maintain the infiltration capacity of that soil. So again, establishing and maintaining vegetation are some of the more critical factors when it comes to minimizing erosion. Topography could be critical as well. The slope, the length of the slope, the steepness can greatly influence both the velocity and the volume of the surface runoff. So again, being aware of where you are and what the potentials are is going to be valuable in what you do. So again, a lot of the long slopes will deliver more runoff to the base of the slope. With that runoff, it's going to have the ability to carry more sediment with it, has the ability to dislodge more as well. Steep slopes increase that velocity. Again, both situations, potential for erosion is increased. The climatic characteristics as well can impact the potential of an area. Rainfall characteristics directly influence the amount of runoff that is generated, such as frequency, intensity, and duration. As the frequency increases, it decreases the chance of infiltration to occur between the storms. Again, that's kind of what we're experiencing this spring is a lot of frequency. We're getting a lot of rainwater, grounds are saturated, water tables are rising. So again, it's gonna be pretty detrimental as far as what happens if we get a lot of heavy rainfalls coming in the future. The intensity of that rainfall can have a lot to do with it as well. Again, the intensity, the duration, how much we get, how quick it comes, that's all going to impact the rainfall character. It's all going to impact the potential for erosive factors. Again, erosion risk increases as those factors become more frequent. Time of year is going to be a critical. Seasonal variations of temperature and rainfall define periods of high erosion potential during that year. In the spring, typically we'll get high erosion potential when the first top portion of the soil first starts to thaw and the ground beneath remains frozen. As that water thaw goes between that ice layer or the snow layer and then the frozen layer of soil, it's going to pick up a lot of sediment and carry it with it. Once it starts to melt, again, the springtime, the soils get a little bit saturated, and the first thaws, the ground basically, once it starts to go, it picks up a lot of that sediment as it goes through. Even low intensity rainfalls can cause substantial erosion. The summer months, again, you get that increased potential for a lot more frequent and high intensity rainfalls. In this case, we've got them now. So we'll start with the first question here. If you're on the ball, Amanda, there we go. Moving sediment and stormwater does not, and this is a single choice. A is stabilize stream banks, B, carry pollutants, C, impact aquatic life, and D, promote growth of harmful algae blooms.
Answers are rolling in. So far, looks like everyone's been listening. We have majority, we have 74 people with A, stabilizing stream banks.
Again, moving sediment will carry those pollutants. The pollutants attached to that sediment move downhill. One of those pollutants that actually attach to the sediment will be the nitrogen, which will encourage the growth of harmful algae blooms. So the proper answer again, letter A, stabilize stream banks, will not. Next one. Let's see. Oops, there we go. What are the concerns for nutrients carried by stormwater and sediment? A, nutrients are harmless. B, nutrients keep soil stabilized. C, nutrients cause excessive and rapid growth of aquatic vegetation, causing harmful algae blooms. And D, nutrients are healthy for aquatic life.
It looks like we have 74 with C, nutrients cause excessive and rapid growth of aquatic vegetation, causing harmful algae blooms.
And that is correct. Nutrients do not help stabilize the soil, and they're not necessarily healthy for aquatic life in the volumes we get there. Okay, question 2. So we'll move on here. How are we doing on time? Okay. And ditches. Ditches are an integral part of the watershed. Basically, they're critical for highways. They serve to convey surface water typically away from or through an area safely with the minimal impacts. Roadway ditches also collect subsurface water from the base of the road and surrounding land, and can divert water to and from the highway. Most often, they carry surface water to natural streams. In many cases, ditches are also used by the neighboring landowners as a means of draining their property. In a lot of cases, ditches aren't designed to carry a lot of these runoff from the adjacent property. So again, issues can arise from that. So we need to be aware of what's going on, who's doing what, and how it's collecting. So again, different types of ditches that are there, again, man-made. When it comes to highway drainage, basically the goal is to control the water within the roadway, not only on the surface, but also from below the subsurface as well. By keeping the subsurface dry, we're going to be able to keep the road a lot more stable, minimize any kind of damage due to pavement, due to that subsurface drainage. So again, trying to filter some of that water away from the base and the subgrade is going to be critical for that as well. Again, this roadside drainage does control water beyond the roadway, but it prevents a lot of that surface water and subsurface water from doing damage to those roads, getting under it, causing that subsurface soils to loosen up. Again, as for the roadside ditch, typically collects surface water from the pavement and carries it parallel to the road to a channel or a culvert where it can be taken away from the road. Diversion ditches, on the other hand, typically run parallel to a road. Not always have to be, but The idea is to divert water before it actually gets to the road ditches. They can differ from roadside ditches in two ways. One, they don't collect roadway runoff per se, and two, they're usually in place to divert excess water. In both cases, if we can lower the water table around the roadways, we're going to get a lot more life and value out of those roadways themselves. So in this little picture here, you can see where the road ditches are by the red lines. The streams are blue, but you can see the ditch drainage basin areas, and you can see how it extends basically beyond your typical drainage area. Road surfaces cover about 1% of the watershed in surface area, but the drainage basins that intercept it collect about 22% of that surface runoff. Again, in shallow groundwater from each. So just as ditches keep the road dry bed, they can also intercept natural drainage flow by capturing the runoff from adjacent hills. Ditches can increase the runoff in natural streams by as much as 300%, which can lead to flooding, obviously. As mentioned earlier, 20% of the natural flow in the watershed may be diverted by the ditch system. This can lead to increased erosion, flooding downstream, and even more complicated when ditches are overscraped and not properly reseeded. Again, pollutant transfer is one of the big problems that we have. And as we mentioned, if the ditches aren't maintained properly, if they're not seeded properly, reestablished with vegetation, the potential for that water flow is basically going to pick up those soil particles and move them downstream. Now, if we had vegetation in here that were mowed, kept clean, it would stabilize the soil. The vegetation would trap any kind of sediment and pollutants that are going downstream. So it would actually improve the whole watershed water quality as a whole. Safety is another issue. Ditches that are overdug can be a problem. So you can see with the mailman here, he pulled off the road and surprise, surprise. So when a ditch is too deep, it can become a safety hazard. They only need to be deep enough to basically to carry the surface flows and possibly drain the water base off the roadway. Most ditches are as deep as they need to be. Making them deeper doesn't really always help. If there's a driveway culvert along that roadway, along that ditch, that's really going to basically be the control of the capacity of that ditch itself. So if you're going to increase the size of your ditches, you should increase the size of your culverts, which we need to be careful. Not only is an expense, but you're going to start moving a lot of that runoff at a lot higher capacity, a lot higher speed. So again, ditches don't need to be this deep. Again, safety issues are concerned. Come in three basic sizes. We got the U shape, the V shape, the trapezoidal shape, and then in some cases they get a little bit too deep or start to erode. You can fill them. There's no best shape. It just really depends on the situation you're in. The U shape ditch is probably most efficient hydraulically, and it's good shape for erosion control. As you can see, it's just basically got the road, the U coming through. Can be built by an excavating machine. It's easy to maintain. Unfortunately, when they dig those ditches, typically in New York State, as they're digging the ditches, they pull that soil from adjacent to the road. And as they dig, they basically dig closer and closer to the road to try to make them a little larger. Two ways of trying to solve that problem might be to cuff that break off and push that ditch back in, just to give it a little bit more smooth runoff, a little bit less of a pitch going through there. Again, trying to make that a little bit sounder and get, and then stabilizing it once you're done. So again, being aware of what you're doing is pretty critical as far as protecting the soil. You've got the V-shaped ditch, which are pretty easy to construct. You can take a grader down and cut a ditch. Of course, the problem is exactly the shape of the ditch, the V, where that water basically concentrates as it flows, and it's prone to erosion. It can be difficult to maintain because of that erosive concentration. Trapezoidal ditch, probably the most efficient. hydraulically, but typically requires a lot more work to actually install. But they can carry large amounts of water. Typically, the flat bottom is going to spread out the flow. It's going to help reduce velocity, which is going to reduce a lot of the erosive problems that are associated with it. As I mentioned, they're more difficult to construct, but if you have the opportunity and you have the area where you can actually construct these and have the need for them, if you reach out to the soil and water, a lot of those guys can help you, and they're more than willing. It's basically what they do is try to protect the environment. And in some cases, your ditches become too deep. You've got a high more capacity that you want to carry. So maybe what you want to do is you can't dig them deeper. If you dig them deeper, again, they become that mail truck dilemma where they become too dangerous. So maybe you'd want to fill them. Typically, in this case, you would put a perforated pipe on the bottom. On the outside, note that there's basically an erosive, some sort of filter fabric here, basically to protect that embankment in case you do both, if you have the opportunity. But you've got the sediment, you've got basically you've got your perforated pipe in the center. So as anything settles through that gravel, it's going to collect in that pipe, and that's going to help move any potential sediment that might be in there, any debris that might be there. It's going to help keep it clean. So again, if it's deep and you want to try to protect not only the stream, but the traveling public as well, this might be an alternative that you count. When it comes to capacity and the depth, most ditches have the capacity they need. Basically, for a roadside ditch, capacity really isn't a lot. In most cases, you'll see that basically the culvert pipes are going to be your limiting factor in all situations. But again, you want to be able to drain the surface of the road and the subsurface of the road. A lot of local roads don't necessarily have this subsurface structure. But again, if we can drain underneath the road as well as the top of the road, get below, typically about a foot below the lower base of the road, that's going to help drain a lot of that subsurface flow and get that volume away from there. Again, if you're looking to design ditches and stuff, again, reaching out to soil and water can be helpful. Again, side slopes are pretty critical. You don't want slide slopes that are too steep. They're going to be not only dangerous, but they're going to be prone to erosion. At best, 1-on-2 vertical or horizontal can be unstable and require guide rail in many cases. Slopes of 1-on-3 are considered good. Again, it's going to help minimize the erosive forces. It's going to get the water off of the road. It's going to help move that off-road velocity, get it away from the road and quit the erosion. So again, a properly built ditch will help maintain itself, helps keep itself clean, and help keep the flow going. Again, some of the unstable ditches you might come across. If a ditch is dug too deep and not stabilized, and this is over by the Cornell campus, where they came in and they had dug, not Cornell, they didn't do this, where the road owners basically came in and did this. They dug these ditches, try to get the capacity, get it going through. Again, went around the tree, but after about a week and a half of time, it started to dry out and settle in. So it basically defeated the purpose of not only cleaning the ditch, but now you get the embankment failure. So again, in some cases, you're going to get a situation where you're going to have to look beyond just moving the water. You're going to have to look at the soil. You're going to have to look at the vegetation and basically try to maintain that water flow without destroying what's actually end up in there. What they ended up doing was coming back. Difficult to see, obviously, it's wrong time of year for that picture. But what they ended up doing was basically putting a subsurface pipe in there and then filling that ditch in to make it less dangerous and decrease that erosive force and keep that whole embankment, the road itself, stabilized. So again, they talk about offset when they're digging ditches. And you can see the before picture where it was, and then there's a poor way and a correct way. Essentially, the offset for the bottom of the ditch should be determined by the design need of the ditch. and the side slopes. A lot of cases, ditches are deepened without actually looking at what needs to be done, and that can be a problem. Ditches need to get wider if they get deeper. And again, not toward the road, they need to go opposite direction away from the road. So again, that can be difficult in a narrow right of way. So again, you may end up filling that ditch with stone and perforated pipe to try to control that. But again, digging away from the road is probably more critical than, more proper, I should say, and keeping that same forest slope along the edge of the road to get that runoff from there. Again, restabilizing those soils is going to be critical. In this case here, you can see they were digging, but they've got a lot of rough soil here. There's not very much ability for the vegetation to actually drain off of that road at this point. If there's going to be high flow on that culvert right there, basically they damage the culvert. They should straighten that out as well. And it's going to substantially reduce the capacity of that culvert. If there's any discharge coming out of there, there's nothing really going to protect it, stabilize that discharge as well. In this picture here, they did a nice job with their ditch. They kept their shoulder, a little bit of filtration going through here, but they never stabilized the soil. The soil itself at this point is probably dry, too dry to stabilize anything. There's been some rain. It looks like it was probably a dry period of time. But again, you can see there's some fine sediment in here. They're starting to lose that topsoil ability. So that's basically going to be pretty difficult to try to reestablish any kind of vegetation on. So if we can, if you can do the right thing, it's going to be nice, but you need to follow through. You got to try to stabilize those ditches, minimize that erosive potential. If you can get some vegetation in there that you can mow and keep it maintained, it's going to be a lot more effective. It's again not only going to stabilize the ditch itself, but it's going to stabilize, well, obviously going to stabilize the ditch, but it's going to help filter out a lot of that sediment that might come down through there, which is going to make it a lot easier to maintain downstream as well. Some of the diversion ditches that there are basically a conveyance channel. If you've got a project, you want to try to keep that water away from your project. Conveyance channel can be constructed to divert that water away from that site. Typically, it'll reduce the amount of runoff that's going to that site. Again, that's going to be a benefit if you're going to try to control that, the soil stabilization within that site. Not dealing with additional water is going to be a whole lot more feasible. Typically, it's not permanent. Again, once you're done, you can basically reestablish your flows. But again, if it is, you can rock line that channel, try to stabilize it in that capacity. In this case, they use some sort of cheap jute matting. If you're going to stabilize it with stone, you want to size those stones for the velocity, and typically line it with fabric as well. Again, check dams are always a good option. Again, sizing your stone properly is going to be critical. If you get a lot of flow coming down and you got a lot of peat gravel, that velocity of the flow is just going to pick that stone up. So again, proper sizing is going to be critical. And again, diversion ditches, if you're trying to keep an area stable, you want to try to keep it so it's somewhat under control. In this case right here, they did a pretty good job. They basically, the flow coming out of the mountain basically was diverted. They had a steep slope, they had a retaining wall. They wanted to try to avoid some of that moisture buildup and water perking through that wall, creating a surcharge on that wall. So essentially they built this diversion ditch. It's a rock line. They stabilized the soil. They put in some vegetation, again, with the intent on trying to make it a little bit more permanent, make it a little bit more aesthetic as well. Storm sewers are the other means of drainage. Typically subsurface collection systems designed to collect and remove surface flow from developments in urban areas. Most cases, the only visible indicator you're going to get are these inlet basins, the catch basins. Again, designed and intended to collect that runoff, collects on those surface areas. Unfortunately, as the runoff runs over those pervious surfaces, It collects all kinds of hydrocarbons, debris, sediment, chemicals, which directly into those pipes below. A limiting factor can be the ability for the inlet grate as well. A lot of these inlet grates are designed for safety, for heel protection or bicycle protection or trip hazards. So a lot of the slots are narrow. That can greatly restrict the capacity of those inlets to take that water in. A lot of the manufacturers have designs and information basically on how much flow each of those designs will take into consideration. Most of them factor in a several-inch height head over top. But again, every situation is going to be a little bit different. It's important to realize that these grates are going to limit your capacity as far as intake. But again, safety is pretty critical as well. So some of the issues with storm sewers, they mentioned they can be either they collect everything that's been collecting on the surface, and basically everything that you might imagine that could fall on a piece of concrete or pavement. So again, excess sediment buildup can build up in these basins as well if they're not maintained. Once you reach a 30 capacity, 1/3 basin volume, to where to the outlet point, it becomes ineffective. Basically, as the water comes in, it churns, it causes that sediment to cycle back into the flow, and then just gets moved out to the outlet itself. So again, if we can do regular inspections, regular maintenance on these things, keep the capacity to less than 1/3, it's going to reduce that potential for transferring that sediment and anything that's in that sediment from going downstream. So just being aware that there's issues is related to that as well. Again, if debris might be capturing a lot of your grate might be collecting a lot of debris. You might get broken elbows, you might get clogged pipes, your inlet or outlet pipes, the grout around them may break and fail under time. Your basins may corrode. And how many places I've come across where they've got brick basins where the bricks have essentially just destroyed themselves over time, and your basin lids are collapsing or your walls are collapsing. Again, regular inspection is important. In a lot of older neighborhoods, there's manholes in the system, but they've been paved over. Several situations when I've gone out to do repave and they were going to reclaim several roads, and they had a drainage system that was invisible, so to speak. I had to go out with a metal detector and locate every one of those lids that had been paved. Some were 6-7 inches below the pavement. That would not have been made the reclaimer very happy. So again, just being a little bit more observant in what you're doing, where you're going, what you've got. Again, full inspection, knowing where your structures are and maintaining. The discharge points. Unfortunately, in a central sewer system, storm sewer system like that, it's got to go somewhere. In a lot of cases, it'll collect it and discharges it with a high velocity, which can cause, if it's going into a stream, cause erosive problems. But in urban areas, in this case, you can see that's coming right off of the roadways. All that sediment, all the pollutant, all the debris, any chemicals it might have picked up, that's going directly into that river. So again, trying to keep an eye on what you're doing, properly maintain and doing a lot of streets cleaning. Try to minimize whatever's going into that waterway if you can. Some cases the systems are older than time, but again, it's still important to keep an eye on what you have, do inspections, do regular maintenance on them. So what can you do? Well, your first line of defense is preventing any kind of erosive. If you can prevent that erosion from occurring, you're going to be a lot more successful. It's going to be a whole lot less chasing downstream than you really need. It's a lot of time and effort that's wasted on chasing sediment. Your second line of defense is sediment control. Basically, if you can control it, if you can't prevent the erosion, then you got to capture that sediment as it's running downstream. can be challenging, can be difficult, it can be very damaging. Again, ditch linings, you say, well, I'll just make everything concrete. Well, that's not always the best way to go. Again, before we clean or construct a ditch, we need to decide which kind of lining we're going to put in there. As you can see from this statement, basically, there's erodibility and then there's retardants. Erosion resistance, basically, and water retardants are two main factors that are considered. The less erodible the material, the less maintenance is going to be needed, and the greater the allowable fall. So again, if you've got stone-lined ditch, you can have a lot steeper and a lot higher velocities. Again, some of the issues that go along with these two are different types. If you've got earth-lined ditch, you're going to have erosive problems. It's going to channel out. It could take any kind of vegetation that might be growing in there. But again, if you've got fabrics, you can always use some sort of geotextile to line that to try to get that whole base, to get that ditch stabilized. In a lot of cases, if you're going to put stone on, you're going to want to put some sort of geotextile under it anyway. That's going to protect that baseline from eroding underneath that stone. But again, reach out to the soil and water. Again, useful resources. Concrete, again, has its benefits, but it also has its issues. High storms, concrete can basically get undermined. Frost can freeze it, cause it to heave, just creates problems later on that we need to try to avoid. As I mentioned, the grass-lined ditch is the best way to go. Vegetation, including grass, bushes, trees, can be planted to reduce that erosion. If you have any kind of question or whatever, again, reach out to Soil and Water. They're a valuable resource that are out there. Again, their goal is to try to protect that soil from the water, essentially. So again, they've got resources and information, and basically, knowledge to help you out to protect that. Again, if you can use vegetation, all you do is mow it and maintain it. So it's a lot more aesthetically pleasing. It's a lot easier to maintain. Some cases, you're going to have to rock line it. Again, not always the best solution, but if you've got a steep run and where it's going downhill, you may need to try to minimize the velocity of those erosive forces. In this case here, this is outside of Green, where they had a big cloud burst that took out the ditches, and they had concrete lined ditches through here. That essentially, that stormwater basically picked up that concrete lined ditches and took them downstream. Caused all kinds of problems down below. So they came back, they widened it, they opened up the ditches, they lined it with large stone. It has been tested, but it's ready to go if it needs. As I mentioned, concrete lined sections can be used, but again, they're going to require maintenance on their own. You got to be aware that the velocity is going to accelerate a lot quicker on something like that as well. A lot of cases, maybe just using geotextile to get the vegetation to grow to protect that soil. There's also other fabrics, as mentioned, as maybe I didn't mention, but as those streams get collected and go through those smaller pipes, to get the same volume through there, that velocity needs to accelerate. So that as it accelerates, it comes out that pipe. That energy needs to be dissipated back to where that streamline can actually maintain that. And in some cases, they've got these man-made products. In a lot of cases, they'll use riprap to try to stabilize that.
Jeff,
Yes.
you do have a question. Is there a maximum size that should be used for lined ditches?
There's a maximum feasible size. As far as maximum size, it's really what you can handle. You might want to consider something else. If you've got ditches that are accelerating that fast, you might want to use check dams or something to try to slow that velocity down. Again, the size is really going to be dependent on the velocity of the flow. Again, working with the soil and water is going to help you determine which situation you're in. In this case right here with this photograph, Supple, Washington County, they had lined a ditch, and the stone was getting mobile, even though it was still moving. So they ended up doing shotcrete when it was dry. and we're able to basically stabilize that ditch. So the size is really going to be dependent on every situation. Maximum size, again, it's going to be a maximum feasible size you're going to be able to handle. And in some cases, it might be just too small. So there may be other methods that are out there that you could actually do. As I mentioned, check dams might be a mean. Try to stabilize it with breaking it down, breaking that velocity, creating falls where it can dissipate that energy. In this case here, they basically broke that whole stream flow by dropping the energy and reduced that potential erosion. This is on a temporary job site where they had check dams that went around the perimeter. And this was out Western New York, where I guess I believe it was Agnes that came through and created all kinds of problems. And they built this series of structures to minimize the velocity of that flow. So again, as far as stone size, every situation is going to be different. And it's really going to depend on the velocity and the volume of the water coming through. So I don't know if I answered that question, but it's really going to depend. Again, there's a manageable size that's going to be kept possible. It's going to be unfeasible as far as using. Just moving them can be difficult. In other creative ideas, this case here, basically they built a little check dam here. It's got a low flow pipe at the bottom that let the normal flow through. But when the heavy storms came through, they were able to basically collect a lot of sediment here. And this is right along the edge of the road. It's actually at an intersection. Basically, they just come in here with a bucket and clean that sediment out. But again, every situation is going to be a little different depending on the parameters, the soils, the slopes, the volume of water. Not everything's a one and done, unfortunately. Again, check dams, maintenance is going to be required pretty regularly. You can see on the picture on the left, there's a little bit of sediment building up on there. But again, in this situation, these check dams solve their problem. The volume of water was accelerating. It was actually bypassing. At the bottom here, you can see where there's a little stake. There's a culvert crossing the road here, which would happen was basically the velocity was too much. It was just bypassing that culvert and flooding people out down the bottom of the road. So again, use of check dams can help be useful, stone check dams. They've got these wattles, these temporary materials. In some cases, they're biodegradable. They don't necessarily have to be temporary. Help stabilize the soil and reduce the velocity, help filter out. In this case, a lot of these things are, this material is actually fairly porous. It's all natural material in here, so sediment and pollutants collect in there. You can actually take them and discharge them a lot easier than you can check dams and that kind of stuff. Again, when you clean your ditches, you just need to clean out the sediment, maybe reestablish the trench line. You don't need to redig every line. Again, you want to try to remove the sediment that's there, but not everything. You don't have to redig every ditch when you're doing them. In some cases, there's reshaping is required, but again, reshaping is removing large quantities of material or widening and deepening the ditch. Again, it can be misconstrued as cleaning, but again, if you're going to do something like this, you basically want to do this from the bottom up. If you go from the top down, you end up with low spots. That can be problems. That can create ponding. That can hold water next to your roadways. Again, creating problems. If a ditch doesn't have any constant fall, you want about 1 to 2% of a slope going through there. You want to try to minimize that velocity. And what you want to do every time is go back and reestablish the vegetation. Always try to reestablish that vegetation. That's going to protect you from the erosive forces that are going down. Hey, a few more questions here. When ditching, which is not the best practice. Remove only what needs to be removed. B, work uphill, avoid flat spots. C, reseed every day to promote vegetative growth. Okay, we're talking about what is not the best practice. Dig as deep as possible to increase the ditch capacity.
Looks like overwhelmingly D, dig as deep as possible to increase ditch capacity.
And that is correct. Again, if you remove only what needs to be removed, that's a good practice. You don't want to over dig. You want to work uphill to avoid flat spots. That's a good practice as well, because you want to maintain that flow line. And again, reseeding every day is going to promote that vegetation growth. But again, pretty critical. Again, this question was, what is not the best practice? All right, next question. Question 4, which is not a means of minimizing erosion? A, using check dams. B, planting vegetation. C, using rain gardens. Or D, exposing soil for extended periods of time.
Looks like overwhelmingly D again, exposing soil for extended periods of time.
And that is correct. Using rain gardens is actually a valuable in reducing erosion, because you're reducing the volume. When you reduce the volume, inadvertently, you reduce the velocity as well. Rain gardens encourage that infiltration. So again, another useful means of doing it. All right, two more things we got to go through here. Let's contact here somewhere. Again, hydroseeding. Hydroseeding typically in most soil and water groups have hydroseeders. If you're planning on doing ditching, work with them, set them up, schedule it, so they can get there within a few days, up to a week, 5 days. So they can get that hydroseed on there. The hydroseed typically has not only a coating that keeps the seed, but it has seeding as well that's going to help establish the vegetation that's on there. The covering is going to help protect it, keep the moisture in, and help promote those seeds from growing. And typically it's just blown on. It's a spray-on application, which goes pretty quickly, but again, they need to know that it's available. And what can be done. Every situation is going to be a little different. Every location of state's going to have different vegetation. So again, work with that soil and water group is going to be valuable. Check dams, again, another valuable resource. Again, pretty simple. Again, building those check dams, again, the velocity, slow that velocity down and reduce that potential for erosion. Again, trap some of that sediment as well. Again, another useful tool. Avoiding over ditching if you can. That's going to be pretty dangerous. You miss that curb, or you're not paying attention, you're playing on your phone or whatever you shouldn't be doing when you're driving. That could be pretty detrimental. Going into that ditch, getting stuck, you're definitely going to have to call someone. That's not something you're going to back out of. So again, if you can avoid those deep ditches, it's going to be a lot more beneficial to the public. And rain gardens, again, simple rain gardens where basically the runoff goes from the concrete or the paved surfaces into a low area where vegetation and infiltration can take place. If you infiltrate it back into the ground, it's going to really promote the effectiveness of that recharging that water, the aquifer below, which is one of the problems with impervious surfaces, that it drains basically the surface water away and doesn't necessarily allow that aquifer to recharge. In proper vegetation, you're going to help filter out and collect some of those pollutants that come off of that surface. And don't over ditch. If you've got a situation that's similar to this, you don't necessarily have to ditch. If the ditch is working, it's well maintained, creating a deeper ditch is not going to really benefit. It's going to create potholes, probably going to irritate the homeowner as well, because they were previously mowing. So again, if we can avoid doing something like this, I don't believe that necessarily needed to be dug. There's no problems with the road. The water flow is actually moving, maybe clear out the pipe where it needs to go, but redigging didn't necessarily solve any problems. All right, that is it for now. It looks like we've just about made it through here. And any questions, let me know. Text them to my email, that's right there, and let us know. And that will conclude today's show. Anything to offer, David?
Nope, and it doesn't appear, I'm looking real quick to see if there's any questions. I don't see any. Just some thank yous. Sounds good. Take care, everybody. See y'all next week on one of our foundational webinars.